നിങ്ങൾ ഈ പ്രോബ്ലം പ്രയാസമാണെന്ന് പറഞ്ഞുകൊണ്ട് ഞാനിതിങ്ങനെ ചെയ്ത് ജസ്റ്റ് ഒന്ന് എക്സ്പ്ലെയിൻ ചെയ്ത് തരാം. That is, we are given only how much water to be treated, that is 3 mld water to be treated. All other data are to be assumed. Here this first method is the actual method for designing, that is we are considering the surface loading, how to arrive the surface loading, that is surface loading and settling velocity are we can equate both of them, that is settling velocity Vs is equal to Q by A, that is also equal to surface loading. We are arriving an a data, that is Q by A surface loading is equal to 8,64,000 Vs, liters per day per meter square. That here the surface loading we can surface loading or overflow rate having a small definition, that is the quantity of water passing per hour or per day per unit horizontal area, that is horizontal area L by B is known as the overflow rate or surface loading. Here we get 8,64,000 Vs, that we can tell like this, that is 1 centimeter per second, that is Vs 1 centimeter per second settling velocity corresponds to a surface loading of 8,64,000 liters per day per meter square, or it is converted into 36,000 liters per hour per meter square. Here there is another clause, that is the settling velocity corresponding to sand and silt having specific gravity 2.65 and grain size 0.001 centimeter or more at 26 degrees Celsius are as low as 0.0102 centimeter per second, that we noted. Okay. In this problem we know we uses alum or ferric ions as coagulants. Then alum or iron flakes may be the size greater than 0.1 centimeter in dia. Then the settling velocity at 26 degrees Celsius be assumed as 0.102 centimeter per second. I think you know up to this. Then the theoretical surface loading associated is we get, that is our this equation, surface loading 8,64,000 into Vs, we substitute Vs as 0.102, we got a surface loading. There is another clause that is corresponding to the experimental study or by experience, they get 75% removal of particles of design category, that is for design category the displacement time should be increased, that it would increased from 40% to 200%. We know we can find out it from only experiments, but here for design purpose we take its average, that is 120% of the theoretical. The theoretic we find out the design detention period from the theoretical detention period. And the surface loading should be reduced. That should be reduced from 71% to 33%. That is average 52% of theoretical. Here we got the theoretical surface loading as this. Then our design surface loading as 52% of that. That is, this is our design surface loading. Then surface area is equal to Q by A. Q we given, that is 3 mld. Find out the surface area. Here in the design criteria, the length width ratio is assumed as 3:1 to 5:1. Here we assumed as 3:1. Then length into breadth, that is, we substitute length as 3 times breadth. We got length as 4.7 meter and length is 3 times breadth, that is 14.1. We take it as 14 meter. As here we assume depth, that is the minimum depth of a tank, 3 meter. Slope, this is also from our design criteria. Slope of sludge removal is 1 in 50. Then the depth of tank is 3 plus that slope plus 0.5 freeboard, that is we got 3.8. Considering the time required to settling the tank of depth 3 meter, the theoretical detention period of velocity for the velocity 0.102 will be depth divided by this velocity, that we get 49 minutes as theoretical detention period. Here we considering our clause 3. Clause 3, that is this one, clause 3. Actual detention time is, that is theoretical detention into, that is 120% increased, that is increased. So we multiply it by increasing, or you can do it by 49 plus 49 into 120 by 100. 49 plus 49 into 120 by 100. That one is this. Okay, we got 108 minutes. We provide a settling tank of this size. Average velocity of flow is, that is, average velocity is, flow means lengthwise, that is 14 by this detention time, we get 13 centimeter per minute. Okay. Next we going to the design of flock chamber. In design criteria, we given that the effective depth of flock tank near settling chamber, that is near here, is effective depth of settling chamber near flock chamber, that is correct. Effective depth of settling chamber near flock chamber, we can take, this is the height of settling chamber, that is 3 meter, 3 point something, but we take it as 3 meter. Assume effective depth of flock chamber as half that of settling chamber, that is 1.5. Detention period as 15 minutes, that is also from design criteria. Capacity of tank 3 into, that is given in your question, 3 mld. From that we find out the capacity of tank. Width of flock chamber is same as that of settling chamber, that is 4.7 meter. Length of flock chamber, we divided it by length by height, width into height. We get length, size is this much. You just draw a line sketch and dimension it. Okay, this is first method. Next one is second method. I think it is easy for you. That is settling velocity Vs is equal to Q by A. A is L into B. Detention period is, that is L by velocity of displacement. Here velocity of displacement is taken as Q by B into H. That is settling velocity, displacement velocity is always downwards. We take considering this breadth and height. Then our equation becomes H by Vs. LB by Q is 1 by Vs, hence H by Vs. Okay. Then we find out the capacity. Capacity, that is 125 meter cube per hour. Capacity of tank, that is the quantity of water to be treated. Then capacity of tank is this into detention period. We substitute the equation 1 to this one. Then here also we take length breadth ratio as 3:1. Then capacity of tank, we substitute the equation as LBH, length breadth height, volume is equal to this. Then we get H and H removed. LB is equal to 125 by Vs. Equation 3, that is this one, 3b square is equal to, we assume Vs, overflow rate as 1.2 meter per hour. That is for clariflocculator, overflow rate is 1 to 1.2 meter per hour. Then we get breadth and length. Depth, here also we assume depth as 3 meter. Slope, we got 3.9 as depth of tank. Hence our tank size is, hence our tank will be 18 into 6 by 3.9 meter. Here we find out the detention period, that is we assumed 1.2 as overflow rate. These all are assumptions. Here depth of tank as 3 and 2.53 hours or 2.5 hours. That is as per the design criteria. The detention period of clariflocculator is 2 to 3 hours is also satisfactory. Next one, design of flock chamber. Here depth is also same. Depth is half of depth of settling tank, that is 1.5. Width is same as we designed earlier, that is 6 meters. Then capacity of tank, we got length is equal to this area divided by this capacity, that is 31.25 divided by 6 into 1.5, that is 3.5. Size of flock tank is